All right, number 13, use Newton's method to approximate the cube root of 10 to 4 decimal places. Okay, well, we need a function that the cube root of 10 is the 0 of. So what function would you plug in the cube root of 10 and get 0? Well, if you undo the cube root by cubing it, then you would get 10 and then minus 10 and you would get 0. So if you plug the cube root of 10 into x cubed minus 10, then the cube root is a root of this function right here. If you needed to approximate the fifth root of 10, then this would be x to the fifth instead of x cubed. If you needed to approximate the seventh root of 20, then you would have x to the seventh minus 20. All right, we're also going to need the derivative of this function, which is simply 3x squared. If you've got a graphing calculator, I recommend typing the function into y1 in your graphing screen, and the derivative, type it into y2. Okay, so we need an initial guess. And the initial guess is something that's a simple number. Cube root of 10 is not, what number do you cube to get 10? That's not nice. But the cube root of 8, we know is a nice number. It's 2. So maybe initial guess is 2. Then Newton's method formula says that, okay, well then our next guess, the next closest iteration is going to be our initial guess 2 minus f of 2 minus divided by f prime of 2. And that just, it's not a magical formula or anything. It does come from a formulation of 2, finding the tangent line to the function at x equals 2, and then at that tangent line you find the 0 of the tangent line, and that gives you your next iteration. Okay. So if you've typed the function into y1 and the derivative into y2, then what you'll enter into your calculator is 2 minus y1 of 2 divided by y2 of 2. And the approximate answer we get there is 2.16 forever. Okay, so we know that the 2 is correct because the next approximation also starts with a 2. Okay, so then the next iteration is going to be our previous answer. So if you're typing this in your calculator, then you can do second entry and pull up what you previously typed in, and then change all of the 2's to a and s for answer, and then y1 of the previous answer, which is 2.16 forever, divided by y2 of the previous answer. The answer you get by hitting second and then the minus sign. If you don't have a graphing calculator, then you're going to want to store this in memory 1, and then you would do recall. You would probably want to do y1 of recall memory 1, so cube it and then minus 10, divided by 3 times recall and then squared, and then maybe store that in your memory 2, and then do recall memory 1 minus recall memory 2. It's messier if you've got a scientific calculator. All right, so then what that approximation gives us is 2.1545036. Okay, so what agrees with the answer above it? The 2's agree and the 1's agree, so now we've got it accurate out to 2 decimal places. X4, just hit second entry on your graphing calculator and it'll pull up this exact same thing. And now your previous answer is 2.1545036 ... And you literally just have to enter again. And then you get 2.154434692. So how accurate are we? Well, anything that agrees with the answer before it. So the 2's agree, the 1's agree, the 5's agree, the 4's agree, and then the 4 and the 5 don't agree. So we have it accurate out to 3 decimal places. And then X5, do second enter, which again, that's too low for you to see anyway, sorry. Second enter, which again pulls up your previous entry, only now your previous answer is this guy, and that's going to give you 2.154434690. So compare it to the decimals above it. Anything that agrees, you're accurate to. So the 2154, actually now we're accurate out to a lot of decimal places, but it just said estimate it within 4. So approximate cube root of 10 is 2.1544. And again, most of the work of this one is done on your calculator. What I've shown here is really most of the work that you can show.